everyone, it's Mrs. Scarpel, and we're going to introduce the topic of absolute value inequalities in this video. So prior to this, we were working with compound inequalities and or compound inequalities, and the work from that is going to help us with solving absolute value inequalities. Now, an absolute value inequality is one that contains an absolute value expression. So we have an inequality and we have an absolute value expression. So an example of a very basic one is absolute value of x is less than 2. That's just very basic. I have absolute value of some unknown number has to be less than 2. So let's think about what that means. Keep in mind that the definition of absolute value is that it's the distance from 0. So we're going to think about what numbers have a distance from 0 that is less than 2. So on my number line, I'm going to have 0, and I'm going to place 2, and I'm going to place -2 on my number line. And I'm going to think about this. Well, I'm not including 2 and -2, so they're not going to be included in my solution. But I want a number that's going to have a distance that's less than 2. So numbers that would have a distance less than 2, if I were to just put some points on my graph, well, 1 has a distance less than 2. -1 has a distance less than 2. 0.5 has a distance less than 2. -1.5 has a distance less than 2. 2.5 does not. -2.5 does not. So hopefully what you're seeing is the only ones that work are values that are in between -2 and +2. So I can graph this. I can say, well, it's not going to include -2 and +2 because they're not included in the inequality, but values really close to -2 and +2 are, such as 1.999999 or -1.999999. And then it's going to be every value in between those two. So I'm going to connect them, every value in between. And we have a graph of a compound inequality similar to what we worked with in the previous section. So we can write a compound inequality for this statement. So I know that my values are going to be less than 2 and they're going to be greater than -2. And remember, when you write a compound inequality, you always have the smaller number on the left and the larger value on the right, and we're using less than symbols. Because what this is saying is x is greater than -2 and x is less than 2. So I'm going to make a note here that this is and, but I'm also going to tell you something that I use to help me remember this. And some people think I'm crazy, but I call this a sandwich. All my values are sandwiched between -2 and 2. And since and is part of the word sandwich, it helps me remember that. So when I have a less than, I'm going to sandwich it between -2 and 2. That helps me remember it, that my ands are sandwiches in between. So how is this going to help me? Well, it's going to help me when I solve it. So if I have an absolute value that I know is less than, I can always write it as that sandwich so that it's between the opposite of C and the value of C. So the expression inside the absolute value is the filling of my sandwich, so to speak. And C and its opposite are the breading. So let's practice this. I have the absolute value of x plus 3 is less than or equal to 2. Well, all of my values that are going to have an absolute value that is less than 2, as we noticed on that number line, are going to be between -2 and 2. So I am going to sandwich x plus 3 between 2 and -2. And I'm going to solve that compound inequality. Now, when it's written as one extended inequality or compound inequality like this, when I subtract 3 from the middle, I have to subtract 3 from each end because I'm solving two inequalities at the same time. So -2 subtract 3 is -5, less than or equal to x, less than or equal to 2 subtract 3 is -1. And then the graph for this, -5 is the smaller number, that's on the left. -1 is the bigger number, that goes on the right. I do have the equal to on each inequality, so I need to have a solid or filled in circle on each of those. And because this is an and, or as I like to call a sandwich, I'm going to connect those values. And this is the graph of my solution. Now, for example B, if I look at this, I have the absolute value of 3c minus 5 is less than -2. So I'm saying that I'm going to have an absolute value that is less than -2. It's going to have a distance that's smaller than -2. But if I think about a number line, I'm just going to make a number line here quick. And I put -2 on it, put some other numbers on it. That means I'm talking about every number to the left of -2. I can't have an absolute value that ends up with any of those values. Since I can't have an absolute value that's going to be less than -2, this is an example of no solution. Because absolute value is always positive, and a positive number is never less than negative. So I'm just going to make a note that positive is never less than negative. So if you take the time to look at what the inequality is actually saying, you can determine, okay, am I actually going to have to write a compound inequality to solve it? Or is it one that doesn't have a solution? So make sure you take the time to read the statement and understand what it's saying before you jump right into writing a compound inequality and solving it. So here's your opportunity to try 3 inequalities on your own, solve them, and graph the solution if possible. Now that you've had a chance, let's see how you did. A is just that very basic one. Absolute value of x is less than or equal to 3.5. So what values have a distance that is less than or equal to 3.5? Well, that will be every number in between positive 3.5 and negative 3.5. So it's just as simple as writing that compound inequality, and then the graph has the two values. I'll put 0 on. And we're including both of them. So I want a solid circle on both of them. And I'm going to connect them because it's every value in between. For B, we're saying I have an absolute value that is less than -1. So I'm going to have a distance that's less than -1. Remember, distance is positive. Positive is never going to be less than negative. So this one is no solution. For C, we have absolute value of 2w minus 1 is less than 11. So we're looking for values that have an absolute value or a distance that is less than 11. So that's going to be everything between 11 and -11. So we're going to write that and compound inequality. We're going to write that sandwich. So I'm going to add 1 on each end, and we're going to have -10 is less than 2w is less than 12, and then I'm going to divide everything by 2. So we're going to have -5 is less than w is less than 6. And then we can write our graph. -5 is the smaller number, it goes on the left. 6 is the bigger number, it goes on the right. We are not including either of the numbers, so those are open circles on the -5 and 6. And we're talking about all of the numbers in between, so we are connecting those circles. And that would be the graph of that solution. So this is how we solve absolute value inequalities that involve absolute value less than a value. The next video will show how we work with absolute values that are greater than a value.